Hello, good evening. SN2 reaction. When the rate of nucleophilic substitution reaction depends on the both concentration and the nucleophile is the SN2 reaction. Such type of reaction is called SN2 reaction. So it is called second order reaction. Rate proportional substrate, nucleophile. The reaction proceeds through a transition state which is a partial attachment of nucleophile and partial detachment of leaving group. This is the methyl bromide reacts with hydroxyl group, methanol plus bromide, rate of reaction, rate proportional, methyl bromide, hydroxyl group. The mechanism, uh, the weights attack this carbon, and this is the transition state. In the transit state, the carbon and oxygen bond is forming, and the carbon and bromine bond is going to break down. And after that, after transit state, produces alcohol. This is the inversion configuration. These kinds of bonds bond between planes away from the others, and this the dark one bond above the plane towards the observer, and this is the normal bone lying on the plane. Three kinds of bonds. In the transition state, hydroxide ion has partially negative charge since it is begins to share its electron with the carbon atom, and at the same time bromine develops slightly negative charge as it is tending to depart with a pair of electrons from the substrate. When carbon-oxygen bond is completely formed, the carbon-bromine bond is completely broken. Energy profile diagram for a SN2 reaction. This is the potential energy, reaction coordinate, this is the reactants, this is the products, and this is the transition state. Transition state. And this is the product. And this is the hydroxyl, and methylene bromide is the reactant. Activation energy. Stereochemistry of SN2 reaction experimentally found that when the levo 2-bromo-octane is allowed to react with sodium hydroxide produces plus dextro 2-octanol is the minus 2-bromo-octane produces plus 2-bromo-octane. That's SN2. In this reaction, yielded a product whose configuration is opposite to that of the reactant, which is set to inversion of configuration. It is also known as Walden inversion, which is complete stereochemical inversion, like turning inside out of an umbrella. Reactivity 1 degree haloalkane preferably undergoes a SN2 mechanism due to least steric hindrance in transit state, which makes stable. A molecular group attached to carbon makes transit state unstable due to steric interaction. So more the number of molecular group, more steric hindrance, and lesser will be stability of transit state, which causes slow rate of reaction. The order of reactivity of haloalkane, the methyl 1 degree, 2 degree, and 3 degree. Here, two-side attack, front side and back side attack. A is the front side, B is the back side attack. Plus octanol inversion configuration is the minus octanol inversion configuration. Only the part B is the possible. For another example, we also represent nucleophile attack in these products. Is the transition state and it is the electrophilic carbon inverse. Also, we can see another example this inversion. This is the retention. This is the front side attack, and this is the back side attack. Inversion convection is possible. That is retention convection is not allowed. Okay, it's all about SN2 reaction. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now. Bye bye. See you again.